Hello, and this is the solution video for Exam 2, Problem 1. And in this problem, I will be solving a sequence recognizer that detects two sequences, 0, 1, 0 and 1, 0, 0. And the important thing is that I've noticed that the sequences may overlap. So if I finish this one, I'm going to have the 1, 0 already done for this. So basically I want to draw my state diagram using as few states as possible and explain the purpose of each state and label all parts of the diagram. So, as with any sequence recognizer, I'm going to start off with my start state. And basically if I get a 0, I'm going to go start creating this sequence, and if I get a 1, I'm going to start working on this sequence. And so 0, and I'm going to do x/c, and this is going to be I haven't detected, and I've detected a 0, is what this is going to say. And if I get a 1, I'm going to go to this state, and now it's going to be 0. Move on to here. If I get a 1 after this, I'm going to go to state 0, 1. And if I get a 0, I'm going to stay put. This one, if I get a 0, I'm going to move on to the next state, saying I've detected a 1, 0. And if I get a 1, I want to stay put. 0/0. And now comes the fun parts. If I get a 1 while in this state, I will want to go to here, and I'm going to output a 0 because I've broken my sequence. And if I get a 0 while in this state, I want to output a 1, and I'm going to go to this state because I just got a 1, 0. So 0/1. And then if I get a 1 while in this state, I've broken my sequence, and I want to go back to here. And if I get a 0 while in this state, I've got 1, 0, 0, which is essentially the same as this. And so I'm going to do a big loop around to make it a little clearer. 0/1. And so now every one of my states has two state transitions leaving. And so my state diagram is complete, and I want to make sure I define my states. And so state defs, start, state, or this is i.e. I haven't detected anything. Yet. And then I'm going to have my 0 state is I have detected the first 0 of sequence 1. And I'm going to label this up here sequence 1 and this sequence 2. And then we got state 1, which is ditto 1 of sequence 2. 0, 1 is I have detected 0, 1 of sequence 1. And we have 1, 0, which is I have detected 1, 0 of sequence 2. So part B was the minimum number of flip-flops required to implement your machine. Well, log base 2 of 5 is 2 point something. We round up to 3. So this is log base 2 of 5 equals 3. Moving on to part C, I need to implement the state machine using a window on the input design. And so since I'm detecting two 3-bit sequences, I'm going to need 2 flip-flops. And this third input will be my 0, so I'm going to need, let me just rewrite my sequences, 0, 1, 0, and 1, 0, 0. So I'm going to have X going into a D flip-flop, Q, Q bar, clock going into D, Q, Q bar, clock, going in, and then I need to make sure I do this in the correct order. So 1, 0, 0 starts. The 1 for this one is here, 0 is here, and then I'm going to need an inverter on X. So this is X bar, and this is going to be ANDed together, and then I need 0, 1, 0. So this is going to go to here, 1, 0, and these all together. I need to OR these two together to get my output Z. And then how many states does your window in the input design have? If the number of states is more than your minimal design, give a brief explanation why it's more. If the number of states is less than your minimal design, give a brief explanation why it's less. And so here, I notice I have two flip-flops. So I have 2 squared, which is 4 states, which is less than my minimal design. Fascinating. This is weird. And hopefully this is a learning experience for you as you think about this. Hopefully you don't spend too much time, but basically the reason why is here, I'm starting with the assumption that I've detected nothing. I make no assumptions as to what's actually in these flip-flops. Because to be honest, if I was to do this, 0, 1 or 1, 0 or something like that was already inputted into the flip-flop, so I would actually technically be potentially in one of these states. But I'm assuming, oh, almost forgot that I haven't. I'm actually starting with a clean slate. With the window in the input design, I don't have this clean slate state. I'm starting with 2 flip-flops that already have potentially values in them, and they're going to output, this is going to output 0 regardless, and as soon as this first 1 comes through, it's going to work. And so, we're working with the assumption that somehow we're going to get lucky that the first 2 actual input bits that are going to get stored in here are not somehow going to make us get a false positive on our sequence. And so, that's a risk we're going to have to take with the window in the input design. And so, basically my brief explanation is there is no start state in window on the input. And how many flip-flops do I need to implement my state diagram machine using one hot design? I have 5 states initially, so I'll need 5 flip-flops. And that completes problem 1.